This is number 1 on the Algebra 1 EOC study guide. It says, which of the following correctly shows all possibilities for the product of two irrational numbers? A couple things that I see here is it highlights the words correctly and all, which means that I've got to make sure that it's accurate in terms of its math, and I've also got to make sure that the final answer discusses all the possibilities, not just a few, but every single possibility. Now, what I also notice is that we're looking at the product of two irrational numbers. Now, when we look at irrational numbers, there are generally three ways we can kind of look at it. The first way would be like a square root or a cube root of something that's a non-perfect square, a non-perfect cube. For example, like the square root of 50. When you put that in the calculator, you're going to see this nice long decimal that comes out of it. That's because the square root of 50 is an irrational number. Or like the cube root of 50. There's no number times itself. That is a rational number. That would give you the cube root of 50 there. So that's the first type. The second type would be something that is related to pi. So 3 pi, pi divided by 4. So if you have pi in any shape or form, then it's going to be an irrational number. And the last type of an irrational number, you'll typically notice by the ... which we call an ellipse. So something like 3.217 ... What that really means is that this decimal goes on forever, so it's a non-terminating, and then it also has no pattern in it that's going to continue to repeat. So we call this a non-terminating, non-repeating decimal. And so these are your three types of irrational numbers. But ultimately, if you took the square root of 50 or the cube root of 50 or pi, they all result in this non-terminating, non-repeating number. So with that in mind, let's go back and read the question. Which of the following sets correctly shows all possibilities for the product, which means multiply, so the product of two irrational numbers? Well, let's look at this. In answer choice A, 1/8 does not fit these three types of numbers. It's not the square root or cube root of a non-perfect number, it's not pi, and it's definitely not a non-terminating, non-repeating decimal. So that's a rational number. Times the square root of 20 is irrational, but we're looking for the product of two irrational numbers. Already, I know that that one's out. So let's look at B. In B, I have 0. Well, is 0 one of these types of square roots of a non-perfect number? Is it pi? Does it have that ... to show me it's non-terminating, non-repeating? Well, the answer is no, because 0 is a rational number. And here they've got irrational times an irrational. Again, we're looking for the product of two irrational numbers. This one's out. Let's go to C. In C, we have square root of 8, which we don't know. It's actually going to be one of those non-terminating, non-repeating decimals, so it's irrational, times the square root of 32. Same idea, irrational. But remember, we're supposed to correctly show, so we got to check to make sure that when we multiply these two square roots together, they really do equal 16. So let's pull that to the bottom here. So we have square root of 8 times the square root of 32. Now, when you multiply with radicals, you can, one of the properties, put them under the same radical symbol. So here I have 8 times 32 now. I'm going to go ahead and break 32 down into a product of some other different numbers. So let me show you. For example, here's that first 8 times 32. If you think of that, it has factors of 8 and 4. So I'm going to put 8 and 4. Now what we're doing here is we're looking for sets of twins, two numbers that match. So here my 8 and 8 match. Because think about it, 8 times 8 is 64. We know the square root of 64. So we could actually take the square root of 64. So that one's helpful. And so then if you think about this one more time, there's my 8 times my 8. And then 4 could be broken down to 2 times 2. So here we have two different sets of twins. So you could circle the twins, okay? When you pull it out, you only get to pull out one out of that radical sign, and then you would cancel it out here. So I pull out a single 8, so that would cancel that, and I pull out a single 2, again, still multiplying on the outside, and that takes care of that. And there's nothing left inside that radical. So if we do 8 times 2, that's 16. Again, let me show you another approach to this. This would have been 64 times 4, and I know both the square roots of those from underneath here. So if I took the square root of 64, that's 8. If I took the square root of 4, that's 2. So another approach, we can look at it. So regardless, they do equal 16. So that checks out. Now, let's look at that. That was an irrational times an irrational, and you know what? The result was actually a rational number. Now let's look at this one down here. Pi is one of my 3 examples up here, so that's irrational. The square root of 27 is another one, so we are again multiplying an irrational times an irrational. So let's look at this, because they kind of have something that looks a little different. It doesn't say pi times the square root of 27 over here. So let's just double check what the square root of 27 is. Square root of 27 is 9 times 3. So if we go the other approach, not doing this whole twins thing, but let me just show you what we could have done here. If I take the square root of 9, that's 3, square root of 3. So here, this would have given me 3 square root of 3, or a different approach. And when I had 9, 9 could be broken into 3 times 3, so that's 9. And then we bring this one down here. Here's that set of twins. How many do you get to pull out? Just 1. So you pull out just 1, and then there's still that 3 inside. So they're the same answer. Now, let's look at this, because there was a pi involved. It was actually pi times 27, or square root of 27. And when I simplified the square root of 27, that gave me 3 square root of 3. And then we still have to multiply that times pi. So usually you put the number, the coefficient, in front of pi. So this would match what they have over here. But let's look at this. An irrational times an irrational results in, this is actually an irrational number. So now I've got the product of 2 irrational numbers could be rational or irrational, which is exactly what this statement says. My answer choice here is definitely going to be C. But one good strategy whenever you're taking the EOC is to always double check that last answer. Make sure that you're confident that you didn't make a mistake here. Well, let's look at this last answer. Here I have 3/9. That is not one of these types of numbers, so that's a rational number. Times 2.1, the decimal 2.1 repeating, is still a rational number. So again, this is not the product of 2 irrational numbers, which would put it out. And that confirms my answer choice of C on number 1.